Greetings and welcome back to the CCNP route training from TrainSignal. My name is Joe Reinhardt. I'll be your instructor. We're going to be looking in this lesson at BGP troubleshooting. In this particular lesson, we're going to once again review the troubleshooting model. We're going to go over BGP specific common issues and resolution steps, things that you might run into, relevant debug and show commands, and then finally review of dealing with Cisco TAC, or the Technical Assistance Center. First, in the troubleshooting model, it's very straightforward and carries about 8 points to it altogether. We have a graphic that goes along with this. You need to first define the problem, know what it is, what it isn't, what the causes might be, what the symptoms are, what things you're certain are related and what things might just be coincidental. Gather the facts, know exactly what the problem is, what's being reported, how it's being described, because sometimes what may be described as one thing may actually be another, and it's just a matter of asking some of the right questions. Next, document the facts. What do you know for certain about this particular issue and problem? For instance, what time of day did it begin? Did it involve a certain set of users? Did it involve a certain geography, certain offices, and so forth? Next, consider the possibilities. What could be causing this? Create an action plan. Implement that action plan. Repeat until the problem is resolved, and then document the solution. This is the flow chart, which essentially goes through the same process. It is imperative to have a tried and true, bulletproof methodology when it comes to troubleshooting and problem resolution. Just as with every protocol, there are some very specific common issues and problems and their resulting resolution that's found within the next couple of slides we're going to be looking at. As with other protocols, we're going to be looking at potential problems that may cause neighbor relationships to fail in formation. In addition, some problems with route advertisement, routes not being injected into the table correctly, routes missing from the table, and then some address summarization issues or problems. Now, there could be a number of different reasons or issues why a neighbor relationship is not being formed. One of the causes could be that the layer 2 process or the interface is down. And the easiest way to be able to determine if this is a problem when you have a neighbor relationship not forming and it's stuck in active or idle state is execute the show interface slot port, for instance, fast Ethernet 0.0 or gigabit Ethernet 0.0 and so forth, and look on the interface that's facing the BGP peer. You should be able to see a line where it says, for instance, fast Ethernet 0/0 is up. That's talking about the physical hardware portion of it. Line protocol is up, and that's talking about the layer 2 process. You may see fast Ethernet 0/0 is up, line protocol is down, and it means the physical interface is fine, but Ethernet keep-alives are not being sent and received on that interface. Sometimes that can just simply be that it's not plugged in, there isn't something on the other side, or you may have a bad cable. If, however, you see administratively down, you know it's been shut down, and you can just simply do the no shutdown command on the interface. For figuring out layer 1 and layer 2 problems, always start at layer 1 and work up, and troubleshoot and solve those layer 1 and layer 2 issues on that particular interface. If it's hardware failure, if it's a cable failure, or something more subtle, that'll be the best way to take care of this particular cause. A second common cause for the failure of a neighbor relationship to form could be an incorrect IP address in the neighbor statement configured in BGP. For instance, in router R1, it should be router BGP 65001, and the neighbor statement for R6, for example, for peering, should be neighbor 10.99.99.6 remote AS 65006. Conversely, on router 6, the statement in the configuration should be router BGP 65006 and neighbor 10.99.99.1 remote AS 65001. If, for example, the IP address is wrong on either router 1 or router 6, the relationship will not form. So the easiest way to figure out if there's a problem is to first execute the show IP BGP summary command. It will show you the state of the neighbor relationship, how many prefixes, if any, are being received, and you can actually see whether the neighbor is stuck in idle or active state. It's the last column when you execute this particular command. In addition to that, you can also execute the show running configuration command to verify that the peer IP address is indeed correct. One of the things that may be helpful is to be able to go in using PuTTY or TerraTerm or Secure CRT or whatever terminal services program you're using, highlighting the BGP section, pasting the configuration into Notepad, then going to the neighbor router, doing the same thing, and then actually look to see if those neighbor configuration statements are in fact correct. If they're not correct, delete the neighbor statements and recreate them with the correct IP address. Another cause for neighbor relationships not forming, especially in eBGP, is because there's not a direct connection between them. Now remember, BGP neighbors, external BGP neighbors, do not have to be directly connected, but by default you have to have additional configuration command in order to be able to know whether or not it's been configured correctly, and it's the eBGP multi-hop command. You can use the trace route and then the peer IP to discover if the neighbor is more than one hop away. You'll be able to tell very easily by the number of different sections and hops are actually being shown in that. And if they're more than one hop away, if they're 2 or 3, you can go back into the statement, into the BGP configuration, and put in the statement neighbor, the peer IP, and eBGP multi-hop. You don't really have to put a number after it, but it's best practice just to put in the number of extra hops away that particular router is. If you don't put anything, it'll do 255 by default. But if it's 3 hops away, you can do 3. If it's 2, you can do 2. You might even just make it around 5 if you want to be just a little cautious. But either way, just try to limit it by configuration. Another thing you can do is the show TCP command. You do it from the command line, and it'll show you whether or not a TCP connection is up and in progress with that particular neighbor. You'll be able to see what it is. You'll be able to see it on TCP port 179, and it'll let you know that a TCP connection is indeed active. So that's something else that you can do. If for some reason that the eBGP multi-hop statement is not in there, you can easily add it. A third cause that's very common for neighbor relationships not forming in BGP is the failure to configure the correct key in the password statement. Easiest way to do this, if you do a show IP BGP summary and the neighbor relationships are indeed stuck in active or idle, go to the running configuration, parse through it, and look for the neighbor, peer IP address, password, and key, and make sure that key is the same on the other side of the connection. Again, this can be helpful if you go into Notepad, actually take that snippet, paste it, look at it side by side, and make sure that one or other things has not been mistyped. Remember, the key is case sensitive. If that statement is incorrect, you don't have to take the whole neighbor relationship down, or actually you don't need to delete the entire configuration. The neighbor relationship would already be down, but you can just change that one statement. You could do no neighbor, peer IP address, whatever the key number is, password, and such, and then recreate it. Make sure it's the same on both peers, and it should come up rather quickly depending on how fast you've set your timers. Another less common but still possible causes for the neighbor relationship not forming is because somehow unicast traffic between the peers is being blocked. It could be a firewall, it could be an access list, there could be a variety of different things. Most likely it's going to be something configured on the one or the other peers that may be blocking it, but if there's an intermediate device, then you need to take a good look at that configuration as well. But on the particular device in question, do the show IP interface and show access list commands. Look at all the access lists, see if anything is being applied on the interface facing that particular neighbor, and if there is, either alter the access list to allow the traffic, or you may have to alter it altogether, delete it altogether. But once you've done that, make sure it's correct, make sure the statements for peering are correct, and then obviously make sure your interface is up. But unicast traffic being blocked can indeed be a cause for neighbor relationships not forming in BGP. Another potential reason for a neighbor relationship not forming has to do with something else in the neighbor configuration that may be misconfigured. It could be timers may be mismatched. Obviously, we've already talked about the MD5 authentication needs to match. But if there's something incorrect about the neighbor statement, you have to actually look first at show IP BGP summary. Show first if the neighbor relationships aren't even shown, then the neighbor relationship is not being established, it's not been configured at all. If it's been configured, you're going to see at least active or idle, and it's going to be shown as a result of that particular command. At that point, you can use the show running config statement to be able to actually go through and parse through the configuration and actually sort through. If you only have a few entries, it's very easy. If it's a lot longer, it can be troublesome. Again, take it to Notepad, paste it there, and then you can actually use the search function to be able to find specifically what you're looking for. If there's a specific IP that's been configured, you know that's correct. You can go to that particular IP, you'll find the entire string of numbers and commands because they'll be listed in order, and that can give you an idea of being able to make some determinations about cause. If something's wrong, you can delete and recreate the neighbor relationship with the correct IP address combinations. For route advertisement, there can actually be a number of different things, but obviously first, if routes aren't being injected or advertised correctly, one of the first culprits, very commonly forgotten, is the auto summary command. Just as with BGP and EIGRP, both have automatic summarization enabled by default. If you don't issue the no auto summary command when you configure BGP, it's going to automatically summarize again to a classful boundary. This is why at the very beginning of the series, we harped a little bit on classful and classless protocols, because there are times when classful protocols or classless protocols can act in a classful manner. One of the many pieces of information that the show IP protocols command will actually display is whether or not summarization has been enabled. If you do show IP protocols, it's actually going to spell out all the different details of that particular protocol, but look specifically for the statement automatic route summarization is disabled or enabled. Now in EIGRP, it'll say is in effect or not in effect, but BGP it's going to say route summarization is enabled or route summarization is disabled. Obviously, you're looking for the disabled command. If it says something different, all you have to do is go back into the BGP configuration, router BGP, the ASN number, and just type in no auto summary, and then it will take that particular behavior away. Another reason for route advertisement problem is the particular route being injected into BGP, in this case by the network statement, it is not matching a route in the IP routing table. Remember, there's a certain amount of matching that has to be done in that regard. First, execute the show IP route command, not just for a particular protocol, but just the command just like that, in order to discover if the route indeed exists in the current routing table. If the route is expected to be there and it's missing, then you have some questions to ask. Is an IGP issue going on? Was it never configured to start with? You may take the same troubleshooting principles and apply them to the IGP to see if there is a particular issue that's preventing that from being installed in the routing table. And if so, you just need to correct that. Another reason why IP routes might not be appearing in BGP just simply has to do with the process called synchronization. Synchronization basically means that it has to exist in the IP routing table through an IGP, static routes, or other means, or BGP will not advertise the route. If you execute the show IP protocols command, look for the statement IGP synchronization is enabled or disabled. If it's enabled, you need to go back into the BGP configuration and put in the no synchronization command in order for that behavior to be turned off. One final cause for a problem with route advertisement issues may have to do with redistribution, which we're going to cover a little bit more later in detail. But if redistribution has not been configured, BGP is not going to pull those routes in. The table has to be populated either through direct injection into BGP using the network statement or through redistribution. And if it's missing, then you'll be able to see where there's a problem. You can choose to use the show IP protocols command and look to see if redistribution has been configured. And if it has, you can do show running configuration, look and see where redistribution might have gone wrong. It could be that you put in an incorrect AS number or a process ID relating to OSPF, but in which case you can correct those particular issues. Now, aside from routes not being advertised correctly in BGP, you may find that certain routes are not showing up in the routing table, which is a little bit of a different issue. They sound the same, but route advertisement is the BGP process actually announcing something out. And whether or not something's being installed in the routing table is a separate issue altogether. So one of the things you may run into in this instance is the default route may not be showing up, and that may be just because it's been misconfigured. Do show IP route and first see if there's a route to the 0000 network to begin with. If it's missing from the table, it won't be able to be injected or advertised from BGP. You can also use the show running configuration command and verify that the network 0000 command is under BGP, as well as the default information originate command. They both need to be there. You have to either redistribute or inject BGP's default route using the network 0000 command. And if they're missing, you can actually add them to the configuration with a fair amount of ease. Another cause for routes not appearing in the routing table itself may also be because of the synchronization issue. We talked a little bit about this before with route advertisement, so we're not going to go back into those particular details. Another cause is in iBGP neighbors, you may have a problem because the iBGP neighbors are not fully meshed. Remember, when the routes are being advertised among iBGP peers, it has a TTL of 1. If they're not all fully meshed, you're not going to be able to propagate routes correctly. You can do the show IP BGP neighbors to verify that peering's happening correctly. And you can use the show running config command, and you may have to do a little bit of digging and detective work in order to be able to determine whether or not the neighbors are fully meshed. If there are connections that are missing, for instance, in the graphic that we have to the left, if these were iBGP routers and 65000, the internet router and router 1 were connected directly, and then router 1 and router 6 were connected, but there was no connection between the internet router and router 6, that would be a missing leg to a fully meshed environment. So if that kind of connection, for example, was missing, then you could use the neighbor peer IP remote autonomous system number command in order to be able to have that working correctly. And then do the show IP BGP summary command. Make sure that all the other peers that you're looking for are indeed there, and that each one of the neighbors shows all the other peers that are required. That'll be your best way of determining whether or not a fully meshed relationship has been configured. Another reason why a route may be missing from the table is the iBGP next hop is not reachable. One of the ways that you can check to see if this is an issue is do the show IP route command. Examine the routing table for the required static or IGP route. And this is true even with eBGP. If the next hop route is not reachable, it's not going to be advertised. If you recall, when we did our advanced lab configurations, we actually had to have static route statements on each one of the routers in BGP to point to the loopback address of the neighbor routers, because it was one hop beyond, so it had to be configured with a static route so that it would show up. If a static route is required, it's very easy to configure: IP route, prefix, mask, next hop command, and so forth. If there's some reason the IGP is failing to install the route leading to the next hop address, you may have a whole other set of issues just related to the IGP. And in that instance, you have to make sure you're looking at BGP as one sort of troubleshooting domain and the IGP as another. They depend on each other, but they can have different issues. In terms of address summarization problems, the most common cause for an aggregate not being advertised is because there isn't some part of the IP address range within the aggregate that exists already in the routing table. The easiest way to be able to determine that is do show IP route, see if any networks within that range currently exist. I keep going back to the example of the ISP I work for. If you were advertising an aggregate address 216.145.0.0 and then the mask is 255.255.252.0 and there are no 216.145 any type addresses in terms of the routing table, it's not going to advertise the aggregate. So make sure it's correctly configured, and then go back and look at it again. Delete and recreate the statement, or find the causes of the missing route if there are any. So the troubleshooting process in BGP requires use of several show and a couple of debug commands that you should be familiar with, and we're going to look at those right now. First the show commands, and then the debug commands. Show commands, obviously you have the show IP protocols. It's going to show your BGP status of your neighbors, your autonomous system number, timer intervals, and networks being advertised in gateways. And this ends up being helpful for troubleshooting neighbor relationships, missing routes, summarization problems, and filtering issues. Show IP route BGP is going to show the BGP routes advertised by the neighbors, the administrative distance. If there is a metric multi-act discriminator value, it's going to show it, and then the route source of the interface. And again, this is helpful for missing routes, summarization, filtering, and other troubleshooting issues as well. Show IP BGP summary is extremely helpful. It'll show you your configured peer IP addresses, your AS number, the number of messages received and sent. If those are 0, you've got big problems. How long the session has been up, the state, meaning is it active, is it idle, is it established? And if it's established, it's not going to say established in the BGP summary command, but it'll show the number of prefixes that are being advertised. This is very helpful with neighbor relationship, local configuration issues, and certain routing problems. The show IP BGP neighbors command, and there's two forms of the command. The first is just show IP BGP neighbors, which will show you the IP address of neighbors, the router ID, the state of that neighbor, peer group if it's configured, the BGP messages and type received, and so forth. However, you can actually also show how many routes that you are advertising or receiving, and actually the actual routes you are advertising and receiving, doing the show IP BGP neighbor, the peer IP address, and then received routes for routes being received from that particular neighbor, and advertised routes for routes being advertised out to a particular neighbor. And this can be extremely helpful in being able to attack certain causes of routes missing and so forth. And this is great for neighbor relationships, local configuration issues, and certainly things related to BGP routes added, missing, or those that should be present. Show IP BGP obviously shows the entire contents of the routing information base. It'll show you your network mask, prefix, all your different path values, AS path, local preference, weight, multi-exit discriminator, and so forth. It's helpful in troubleshooting missing routes, filtering problems, and general troubleshooting. The debug commands, these are more for real time than just trying to look at settings. But you can do debug IP BGP peer, the particular IP address, and then the updates. It's going to show you everything that's going on with neighbor adjacencies and relationships. And it's helpful in troubleshooting routing issues, routing update issues, and neighbor relationships. The debug IP BGP events is helpful in looking at different network events, interfaces that go up and down, processes that change, the neighbor relationship change, and so forth. It can help with convergence issues, interface flapping, and routing update issues. Now we're actually going to examine up close and personal some of the different commands that we've talked about for troubleshooting purposes. You can see we're consoled into our router 1. We have router 6 right behind it here. We could actually start off with the show IP protocols command. Of course, it lists the IGRP because that's the IGP running on this router. But notice here, it lists the autonomous system number. It shows any configured filter lists incoming or outgoing on a global basis. This tells you that the synchronization process is disabled. This is the no synchronization command, which can cause a lot of trouble. Automatic route summarization is disabled, meaning no auto summary. Now notice here, it's talking about an aggregate address right here for one of the things that we configured. So you can see that information. It shows neighbors with some specific things that have been configured. We have some route maps here for AS path prepending and wait configuration. Maximum paths 1 is we would have to use the maximum paths command under BGP to change that. And then obviously different things that are being brought by the peering routers. So that's one command. Obviously, show IP route BGP to show all the routes specific in the IP routing table in BGP. You can see down here is that aggregate address. Notice it's to null 0. That's important. Show IP BGP summary, which is your best friend when you're looking at neighbor relationships. Notice it shows the peers, the autonomous system number, messages received and sent, the version of the table, how long they've been up, and then it also shows the number of prefixes. If you've only advertised a small number of prefixes and there are more or less in this particular statement, that's a good thing to look at. You do show IBGP neighbors. Let's do 10.6.6.6. We want to do this by itself. It would show us all the gory detail about the neighbors. I'm going to execute out of this command because I want to show you something else. Advertise routes. What routes are being advertised from router 1 to router 6 by BGP? Notice the default route that's being advertised at the top and then a whole host of prefixes along with AS path information and such. Now we want to actually look at what's being received from router 6. The same information, but it's showing what's being received, what's being brought back in and being advertised. So that's a very, very helpful command. Another thing that you can do is you can do debug IP BGP. Notice here you've got a whole bunch of choices. You wanted to look at BGP events, for example. We could do all the messages between here and router 6. For updates, clear IP route. We'll clear the routing table. Notice now we're seeing some update commands. And actually, the neighbor relationships have been reset. So show IP BGP summary, idle. If we wait a few moments, the neighbor relationship could come back up quickly because we've shortened the timers to make it happen more quickly. There we go. Notice it's showing it's done initial updates from. Notice now there's a whole great deal of information that's being generated specifically because we're looking at the update information coming from the router that's the peer. So we're going to turn this off now. This is one way of being able to just demonstrate a lot of the things that are available with BGP. You can see if you ever have any questions about what's applicable in BGP, just do show IP BGP question mark. You can see there's an entire cacophony of different things. It can even show you route maps. You could also just do the show route map command for that, showing all of what's going on in these different packets that have been sent and received. And those are a little bit of the troubleshooting commands that you can use with respect to BGP. Now we'll just have a brief review of the Cisco TAC process because we've talked about this a number of times already. A little bit about understanding TAC, about severity levels, how to open a case, information to have, how to work the case actively, and a little bit about TAC case etiquette. So you remember the TAC stands for Technical Assistance Center. It's the 24/7/365 help desk essentially for Cisco customers regarding all the different products in the Cisco portfolio. And there are a number of different centers. I happen to have a soft spot in my heart for the Sydney, Australia center because I've been on the phone with them a number of times and really enjoyed working with them. San Jose is good too. Haven't done as much with Raleigh and Brussels, but there are other centers, but these are the main ones. Severity 1, network down emergency. Your network is significantly impacted. There are all kinds of impacts to your business, and you and Cisco will commit 24/7 resources to resolving the issue. Severity 2 is the network's severely degraded. It's up and it's operational, but it's at a significantly degraded capacity, and it's impacting business operations. So this is considered less serious, but it's probably resolvable during normal business hours. Severity 3 is it's impaired, not down, not degraded, but impaired to some degree, and should be resolved, but not in an all-out emergency. And again, this is a more of a 9 to 5, 8 to 5 business type of environment. And severity 4 is just assistance with configuration or product questions. You can open a TAC case by email, on the web, or by phone. There are a number of different ways. I happen to prefer on the web because it tends to go more quickly, but some people feel better about doing it over the phone. Information to have ready, make sure you have your service contract number, the product or chassis serial number, which is usually visible either on the chassis itself or you can get it by configuration in most cases. The hardware configuration, the model number, the location of the product, whatever you think the severity level needs to be. And then some helpful things to have is a good description of the issue, a sort of a good summary title, a history of the problem, the network topology, output from different commands such as show tech, and different logs. Those are things that are going to be helpful to the Cisco engineer. You can actually attach those and other notes in the Cisco TAC request tool. Also work the case actively, send and receive. Obviously you want regular updates yourself, but make sure you regularly update the TAC engineer to what's going on. Keep regular communication open and close the case when the issue is solved. Don't let it hang on for a long time. Make sure you treat the engineer with courtesy and respect. Make sure you have separate TAC cases for separate issues. You do control the severity level. Escalate to the TAC duty manager or supervisor if you're not getting the type of service that you want, and pass along compliments to the supervisor if indeed they've done a great job. Some terms, obviously, Cisco TAC is the Technical Assistance Center. Severity 1 is a production hard down emergency. We sometimes just call it a P1 or a network down emergency. Severity 2 is the network is severely degraded. Severity 3 is the network is impaired but largely operational. And then severity 4 is just informational or configuration assistance. So what have we gone over? We once again reviewed the troubleshooting model, looked at BGP-specific common issues and resolution steps, relevant debug and show commands, and again, how to deal with Cisco TAC. Thank you for your kind attention. We'll be moving on to other topics when we meet again.